Radical Dude here, and today we're going to talk about proving triangles congruent for the geometric proofs. Let's take a look. I give you two triangles and I say they're congruent. What does that mean? Well, it means they have the exact same size and shape. That's what this symbol means, congruent. So, let's look at the parts. Well, angle A is going to be congruent to angle D. Nice and simple. And angle B will be congruent to angle E. And angle C matches with F. Okay? Those are the angles. These are the angles. Now we have the sides are also going to be corresponding and congruent. So if I take this side, which I'm going to call it AB, then I would say AB is congruent to this side here, DE. And if I take AC is congruent to DF. And BC finally is congruent to EF. These are the same. So there are three pairs of corresponding angles, three pairs of corresponding sides. But what we found out is there's a way to make sure, that's the bell, it's time for me to almost go. What we found out is that if I can make, I don't have to measure all of them. If I could just measure a few things of one, it automatically corresponds to the other. And these are called postulates. That means they're things that you accept as true automatically. So one of the postulates says this. If I measure this side congruent to this side, and I measure this side and it's the same as that side, and I measure this side and it's the same as that side, everything else about this triangle will be the same as this one. This angle will automatically correspond and be the same as this one. This angle will be the same as this one, and this angle will be the same as this. So I don't have to measure all six things. All I have to do, if I measure these three things and then make sure they're the same as these three things, these triangles are congruent by side, side, side. You would say side, side, side of one triangle is congruent to side, side, side of another. That doesn't mean they all have to be equilateral. It just means that this side is congruent to this one. And then this side 2 is congruent to this one. And then this side 3 is congruent to this one. Once you've established that, all the other parts are the same. They're corresponding parts. And you would call them corresponding parts of congruent triangles are congruent. So this angle would be congruent to that one. And another popular one that they found is the same way. All you have to know, if these two triangles, I measure this side is congruent to this angle I can measure is congruent to that, and then this side is congruent to that. If I have this statement true, I've measured these three pieces and these three pieces, and they lined up, they correspond to the same. These triangles are congruent by side, angle, side. So you would say side, angle, side is congruent to side, angle, side. I don't know where that came from. There it is. Okay? That means automatically, once we've measured these things, automatically this angle is congruent to this angle. This side here would be congruent to that side, because it's side, angle, side. And the other popular postulate on geometric proof for triangle congruence is if I measure this angle congruent to this angle, this side congruent to this side, and this angle congruent to this angle, then they're automatically congruent to each other, and all corresponding parts are congruent. And this one goes by angle, side, angle. Angle, side, angle is congruent to angle, side, angle. And once you have that down, then all these other corresponding parts are the same. This angle up here is the same as this angle up here. Okay? This side here would automatically be the same as that because you've already established this. Angle, side, angle. Those are postulates. There's a few more, but those are the three popular ones. Then you can play around. You can do a hypotenuse leg and angle, side, angle. Or angle, angle, side, I should say. Anyway, so those are the three main ones. This has been Radical Dude. I hope I was able to teach you